Hi everyone, I'm Philipp. I'll talk a bit about monitoring and what we can do around that and what your problems might be. So kind of the idea for this talk started when I saw that tweet, like as soon as you have kind of a distributed system, stuff gets harder. So it's a bit like you have this murder mystery, you have some pieces of information here, you have some pieces of information there, and then you start poking around, and unless you like detective work, this is not really where you want to spend your time in general. And often you have something like this. I guess a lot of you will recognize the applications that this is you pretty much sitting there, and at some point you think like, well, everything is fine, until not everything is fine anymore. At some point you just figure out, well, everything is on fire and it's too late now. And we kind of want to find that before it's too late and we're going that far. And kind of the final thing is, as soon as you have something distributed, whatever you want to call it, microservices, anything talking REST, you want to have probably some aggregated logging, and you also want to be able to correlate some IDs. Like you have a request going in on some end, and it's kind of like working its way through your system, and then you kind of want to see like what has been going on or what has been slow, because that is often a very hard question, like what is actually slow in my application? Where is that thing that is slowing everything down? So kind of we want to log and monitor all the things, and since it's a very short time slot, I'll just pick out 3 of them. Why am I even talking about that? I work for Elastic, the company behind Elasticsearch, Logstash, Cubana, Beats. We have these products, like, they were often called like the ELK stack for Elasticsearch, Logstash, and Cubana. We have now added Beats, and so that Beats doesn't feel left out, we renamed the entire thing to Elastic Stack. I'm part of our infrastructure team, so we're kind of the ops people in the background running internal services, AWS, Docker containers, all these things. And I always say, like, this is a Unix pipe. I kind of piped it out into the developer advocacy, so I talk about all the good stuff we do, while still staying in touch with the monitoring. So I'm using a highly monitored Hello World application now. You can even do some requests against that. You'll see that in a moment. So this is pretty much our stack, but yeah, we can talk about that later. It's not that interesting right now. What I want to focus on is this one. I've stolen the graphic, but I really think it's a good one. This is kind of logs, metrics, and traces, and kind of how they play together. So logging in general is you have an event, and you want to store that event and see what has happened. And then you have metrics. Metrics is something you can aggregate. This is like, I don't know, response times or memory usage or heap size or something like that. This is often a number you can aggregate and put together. And then you have the tracing thing, where you want to take like one request and follow it through the entire system going on. Like these 3 things kind of are combined. And ideally, you're not doing just one of them, but you kind of combine all 3 of them, and you can kind of get into the middle of all the 3 circles to see what is really going on and putting all of that together. So to do some logs, I hate just slides. We need to do that live. So everybody who has a phone or a laptop out, you can do some quick requests as well. So if you go to Xiera.wtf, that is kind of like my very minimalistic application, and you can just do some requests, and then we'll take a look at them live. So why Xiera? That is, if you take my last name and rotate it by 13 letters, good old rot 13, that is what you get. And it seems to be pretty unique. And since it's a demo, I just use WTF because that feels like the right thing for a demo. And it's not very fancy. It's just generating some requests, so you can get like a regular 200. We can add 200 with a parameter. If you add your own name here, we can try to find it in our logs afterwards. We have 500s as well. So, for example, we can get, my bad, something went wrong. We'll try to find that afterwards. Or another 500 where this is indeed null. Basically, this is a good old null pointer exception. You could get a 404 slower request. You can get all of that out of the application. Now we want to see what is this actually doing. So you can do the classical logging, which will look something like this. So this is my application called frontend. You have a file called log, and then you have entries like, let's go to the very end. Like here you have the good old stack trace. We have quite a few stack traces. Or you have one request here. You can see info. You have a lot of information there. But this is not really that easily digestible. So you might want to parse it out to actually find anything in there. But nobody wants to write regular expressions, I hope. So I'm not a big fan of doing that. I generally tend to write out everything to JSON directly, which is maybe not that readable for humans, but we can then very easily collect that information. Since it's JSON, every system that already knows JSON can just use that directly. So just to give you a quick idea how this might look like, this is, if you have not seen it, Cubana. This is the current release candidate. So if you've seen all the versions, I always say version 3 is black, 4 is white, 5 is colorful, and 6 will be blue. That is because the colorful thing was not very good or very well readable for colorblind people, I've been told. So we can see you did some requests here, like we had fewer requests over here. We have more requests here. So in the last 15 minutes, we have 1,500 requests approximately. And then you could just say, like, I'm only interested in my applications which are Java. And we could just filter down that I have a field called application then it already suggested Java. And you can see my Java application has now logged in the last 15 minutes 360 requests. And we also have some other fields here. For example, you could say, like, I'm only interested in, let's say, we have info and error messages. And I'm only interested in the error messages now. Because info, well, who cares about info? Who looks at info messages? Let's take a look at our errors. So for example, one here, you can see somebody called Merly. Hi. Did something, and afterwards they called the null thing, which is basically just throwing a Java null pointer exception. That's the thing that Java is doing. You have the entire stack trace here. And you can see what has actually been going on. Like you see the time, the server. We've added some cloud information. So for example, this is the information about the AWS instance where this is running. You have the IP address, timestamps. You have all of these informations, and you have the stack trace. So you can see what is going on. The other thing you might be interested in stack traces is generally like how often do these stack traces appear and like what is my distribution of stack traces. So we have something else done here that is also part of the JSON driver, a stack hash. Basically, I take out all the parts from my stack trace that change between calls. So I only keep in one stack trace what stays the same between different times you call it stack trace. So you can actually aggregate together the same stack traces into one. Let's see what our distribution for stack traces is. So we can graph everything very easily. I'm just doing that live. Let's go for a vertical bar chart. And now I say I'm interested in, I have collected log files, so this is the right index I want to use. And I want to see that based on the stack hash. So here we have a field called stack hash. I'll make this slightly smaller so we can see it here. And you can see this stack trace here has happened 47 times, this one 24 times, and this one 23 times. And if anybody has entered their name as a parameter, we could then even break that down and see like how many users have been affected. So we can say, I want to split this up into different terms, and I have a field called json.name, which I've added explicitly. And you can see, okay, most of you stuck with the default Philipp username, but some we have Jimmy, Merly, Adnan, Paul, Anders. You also got some errors. And then you can actually tell which stack traces should you take care of first, like which ones happen most often, or which ones affect the most users. All of that you can get out of that. To see what is actually going on. So that is kind of the logging side. Then we have metrics. I'm using Spring Boot. It doesn't really matter. But what Spring Boot does is it exposes some metrics by default. You have stuff like health and /metrics, and they just give you some statistics of what your application is doing. It doesn't really matter what you're using in the backend. I just care about some metrics that you're exposing. It could be custom, or it could be just something given here. And just to give you a quick idea of what that looks like, it's exposed by HTTP, so I can just do a curl. You need to authenticate, and I've used the very secret admin and secret. And and I want to run that against my Java application. For example, we could do health, and then it will tell me, yes, the application is up, and then some stuff about, I don't know, disk usage. Or you could do metrics, and then it would tell you more. Here you have, for example, like how big is your heap right now, and stuff like that. So you can then collect that, aggregate it, and actually visualize what is going on your system. And we have integrations both to HTTP, so anything that speaks HTTP, and JSON you can easily collect. But you can also do deeper integrations in other applications. So for example, in the Java ecosystem, there is this thing called JMX, which exposes metrics. We can collect that as well. And I've just done that just to give you an idea what to do with that then. We could just visualize something again. I'll use a different visualization now. So here we have the number of documents in our entire system. That's not that helpful, but I'm interested in the Java heap because your application might run into an out-of-memory exception at some point if your heap is full. So let's see how our heap is developing over time. And I don't want to do a count of all my documents. I want to do a sum of one of my fields. And that field is called if I could type it, jolokia.metrics memory heap usage used. And here you can see the heap usage overall. But then you might say, how is that distributed over all my instances? Since we're using a distributed system, we can actually break that down. So I have a field called b.name, which has like nice readable names. You're generally hitting the front-end instance, but we have two others running as well for your calls. And yet you can see here how the heap usage is developing over time. And this is the last 15 minutes, but you could say, I don't know, the last 24 hours. Was there any change? And you can see, it has been growing here. And suddenly these two fell down for no real good reason, whereas the other keeps slightly growing. But this would be a nice way to see, like, is your heap growing? Will you run into an out-of-memory exception at some point? Is it just to see what is your application doing? Whatever metric you have, like number of requests, number of errors, 404s, 500s, you could graph all of that out to see what is actually happening in your system. And finally, traces. So tracing in a distributed system is kind of important because otherwise when somebody comes to you and says like, your application is slow, you have a very hard time debugging what is actually slow. And you can do something. In Java, it's the plugin is called Sleuth, but it doesn't really matter. Sleuth is like the detective. So you will get some information like that in your logs. And what you have in there is something like you have an application name. So you're talking to the front-end application. You have a trace ID. The trace ID is like, that is once a request gets to your system, you always keep that ID you generated the first time you get it, and then you keep that in an HTTP header and keep it as that request is kind of like propagating through your system to get the final result back to you. So that is like one call a user does. That's how you can follow that. Then you have the span ID. That is kind of the unit of work. A span ID is pretty much like a method call or a function call you would have. So you know how long does one specific method or function take. This will be important to find out like which method is actually slowing down stuff or where do I actually spend my time. And then there is this thing called Zipkin. Zipkin is kind of one of the possibilities to do open tracing. There are other systems by other providers like Uber has recently open sourced or pushed Jaeger more. AWS is doing X-ray, but they're all kind of doing the same thing. You can send these tracing informations and then follow like one request through the entire system. So to give you a quick idea how that looks like, if you have, I don't know, let's do a Sleuth 500 here. And that took some time, and then I can just say, I have Zipkin running here on the monitor. You can go there if you want to as well. And then you can say, give me all the traces. And it shows you, okay, the slowest trace we had took 1.5 seconds. That was the one I just did. And the red thing means you got a 500 back here. The blue ones mean you got a regular 200 back. And if you click on that, you can actually see you had two methods which were used in there, actually. So you have call bad, which took around 1 second. And then it called another method called bad, and that bad thing just took 61 milliseconds. So you spend nearly all your time in this one method here. And if you would call more than one method, if you had the deeper nested, you could actually see like how they interact and how one calls the other afterwards. And then here you could see that call bad. This is the one thing where you want to see why is this slow. Well, I kind of cheated. There is a random sleep in there, so that's why it's slow. But the real application, you would know, like, this is the method that is actually slow, and this is where I want to debug stuff. And the other thing you might want to do is, like, while you develop, you want to take a look, like, what is going on with my one request? And luckily, there is a plugin here that is called Zipkin. It's currently, I think, only available for Chrome. There is one coming out for Firefox as well. And when you do a call now, like I do a slow 200, like it's taking kind of a long time. And I don't know why this is so slow. So with that plugin, you actually have that link to the trace. So you have the trace ID here. You can just click on that. And then you can see what it was doing. So it was calling the method call, which entirely took like 1.9 seconds. And then this called like slow, which took 190 milliseconds. So this one here again was the thing that was slow, whereas this one here was fast. Like in here, something has been going on and not being made proper progress. So this is where you want to debug stuff. Okay, and that's what kind of it already. I always say like you have all these building blocks, but you kind of need to put them together into the right way to actually monitor and see what is going on with your application. So the 3 building blocks I have used now were kind of logs in a structured way, metrics, anything that you can aggregate, and traces to actually follow one request through your system and find slow requests, for example, or bad requests, and see what they have been hitting. If I have 45 minutes or 1 hour for that talk, I could do other stuff like monitor the uptime of applications, metrics on the operating system level, more metrics from my servlet container, for example, security, auditing, stuff like that. But yeah, I think we're out of time. If you want to try that yourself, you can log into the Cubana instance and you get some dashboards to try it out. And I have all the code on GitHub, so you can just check it out. It's all automated, Terraform, Ansible. We'll just throw it up on AWS and you can run it yourself. Should be pretty easy. And with that, that's pretty much it. Oh, I have a lot of stickers over there. If you want stickers, grab them. And before I get thrown off the stage, I always take a picture with you so I can prove to my colleagues that I've been working today. Smile, everybody. Very nice. Thank you, and I think we have time for questions. Yeah.